this is a Google AIY Vision kit, which has a Raspberry Pi 0W and a camera and a neural network chip, which if you smile, the button goes brighter, and if you frown, it turns blue. So it does a little facial expression detection.
Which chip? Is it? Which AI chip?
It's a company that Intel bought that's...
Movidius?
Movidius, that's it.
Oh, yeah. From San Mateo.
Yeah. I don't remember which part number, but you can look it up. But the
Ralph, smile.
The thing I actually wanted to show was my little display case here. I built, I got some plexiglass from Tap Plastic and just used basic hand tools to cut it out and glue it together, and it came out very nicely. Before I had a cardboard box with a hole cut in it and some gaffer's tape to hold it in place.
Turn it.
That's more the spirit of homebrew.
Yeah.
There we go. Smile again. Okay. That's real homebrew, Ralph.
Yeah, exactly. So this is, I'm planning to use both of these in a project for Maker Faire. So that's just a partial exposure of what I'm doing. Okay. Oh, and the display also has VGA and video input, and this is a little microscope, so that you can use the select button here, and then see the table.
See what's on the table.
See what's on the table up close.
It's alive.
So
That's cool.
it doubles.
Thanks very much.
Need another arm.
Let's show you down. Sure.
I see a plug right there.
Yep.
Very much. Oh, yeah.
Let's see. So I've been around for like 3 or 4 years now. I think it's 4 years now. Can you hear me?
Now we can eat that microphone.
This close?
Yeah.
Okay, so I've been around since like fall of 2014 and just been slowly learning. And last year, an organization came around, TikTok Robotics, and they came and did this awesome presentation, and I'm like, that's the company I want to work for. And at the end of their presentation, they're like, and we just folded. And they said that the robots that were on stage were up for grabs if you know, you did something with them. So this is one of the robots I inherited from TikTok Robotics. And I believe Tony, somebody's here. I think you've worked on this robot at one point, because I was told I should talk to you at one point. But so basically, it's a parallax platform. It had a propeller board, a parallax propeller board. It had a, or it has a motor propeller, excuse me, a parallax motor controller. It's got this power board here. It's got 3 sonar right here. It's got obviously 2 motors and encoders on the motors. And I'm still learning this. And I have a really good friend of mine who I know from the NASA Robot Challenge. There's a bunch of us within this community that were part of the NASA Robot Challenge 2014 through 15-16. And so within that community, I met somebody named James Loftus. And so that person has been mentoring me on this robot. and he's been challenging me to like get to know the boards and to get familiar. And he said, go on this schematic, software. And so I've got a schematic going on the at least 4 things here. I've got the Raspberry Pi. I've got this Easy Connect that's on top of the Raspberry Pi, and then I've got the. I'm very proud of this because I've never done this before. And I've got the power board here and the motor controller. So I've actually had to like read the specs, understand how to connect these. I actually connected my Raspberry. Oh, so what I did was I took off the parallax board because I heard that that's like really an intense. I think Camp said he's worked with that propeller board before, and parallel processing. Yeah, and so Raspberry Pi seems to be, what we all use around here, so that seems to be something I can have access to. So I put Raspberry Pi on here. I got this Easy Connect just so I can get access to the pins. I've connected the Raspberry Pi to the motor controller, and obviously have it powered up through the power board. And I've officially loaded Raspbian. And so I'm baby stepping my way through this, and I'm opening up the ports. My next step is to communicate the Raspberry Pi to the motor board. And ultimately, my goal is to have a very specific use case. Somebody has proposed a project to me that I have fantasies of pitching at RoboBusiness in September. Because I know there's, Ubiquity was there last year, and I was very jealous, and I want to go up there one day and do a pitch. So hopefully by September I'll have this up and running with a particular use case, and I'm looking forward to showing it along the way. So between now and September, hopefully we'll see this evolve. Thank you.
Fun project.
Okay, so last month I showed the load cells working, and I had a hard time getting started, so this time I actually put something up on the desktop. And this, what you're looking at here is Ubuntu running on an NVIDIA TX2 GPU board.
Nice.
And I wrote some stuff in OpenGL. If I double click, maybe it'll actually run. There it goes. And so it's a little bit more extensive this time. I managed to get the GUI part working. I have that code if anyone wants to play with OpenGL and Glut. The nice thing is it runs on everything. So, want me to put this on the table? I can do that.
Oh, yeah.
I can. Now, of course, every time you move your robot, it has so many wires. It may or may not actually work. But let's hope for the best. And the antenna robot might zig. That's okay.
Didn't need that.
It'll work, it'll work. Unless that falls, then it
Settle
won't.
down, guys.
Let's see, so...
Red one is positive.
yeah, so red is negative, right?
Negative.
Red is negative.
That's the blue wire
Negative,
first.
negative. I'm positive that red is
Along with
positive.
leads the anode, right?
And yeah, I almost brought some flash paper. I don't know if you guys know what flash paper is. And I have a little magician's thing, and I was going to hook it up and go poof, and go, whoa, this is not going to work. Actually, it will work. And let's bring that around here. And hope for the best. So I'm going to plug it in and pray. Plug and pray. This it goes like this, right? So far, so good.
Step away.
Okay, now, theoretically, if I turn it on, we should see data. We should see data.
Hey,
There
look
it is.
at that.
It ain't over yet. So I have to lift it up because there's load cells on the bottom, and we need to, what in the load cell business called tear, which is basically just a word for zeroing the sensors. So this is the robot leg of what used to be Watson, is now Karen. And I should be getting data.
Your robot is transgender.
That's not working. Up there goes. Okay.
Non-binary.
So what you see here, this is the center of mass. That's the heel. That's the toe, and this is the toe here. And what we've added, if I have my mouse, did I lose that? Yes, I did. Is we now have this up here. So this is controlling the servos. It's actually going over Zigbee from the board over there to the processing board. And if everything works, I can enable all the servos and press DaVinci.
Nice.
And that's our DaVinci. So this is the extended, which is just a little bit longer. Go back to DaVinci, and then the squat position, which is that. So that's the improvement we made this month over the last 30 days. And next month, we are going to fix all the wiring here, make things run a little better, get the IMU on the board working, and mount all the electronics on the top here, and have everything level. And we'll start doing our algorithm as it's going up and down. We keep this in the center here. The idea here is we want to make the foot smaller, because this foot is very big.
Big
but
foot.
Yeah, it's big foot. If the foot were smaller, it would fall over. So for those that haven't seen the full model, which is the other leg and the upper torso, which we had actually walking here a couple years ago,
It's awesome.
this model is well improved. I've been working on this since I first started going to HBRC in 2007. So this is about the 8th or 9th rebuild. It gets better every time. And if you don't quit and you just keep working at it, you can't fail, right? So pretty much. It used to be called Watson. It's now Karen, which is trademarked C-A-R-E, capital I-N, and it's the home care market. We don't have to move fast. We just need to navigate around the house, walk up some steps, keep an eye on grandma, and it has to be low cost. So to reproduce this particular leg right here, the bill of materials, if I really got it down, is well under $1,000. So
This is a biped?
right
This
now
is part of a biped.
right now it's Eileen or Peg or whatever her name is with one leg. Yes, it is a biped, and I just removed the leg to rebuild this leg. The old leg couldn't collapse this far. This is where the hip would be. So the important part of this model is that I can start it lying on its back or on its front and flip down, get the foot on the ground, and then pull the torso up and then stand straight up. And so really it's going to fall, it has to be able to get up. So that's Karen.
It's going to fall.
Yeah, it's going to fall sooner or later. Okay, any questions? Do I have any questions? I didn't.
When do you think you'll be finished with this?
2027 is the new projected date. And so, yes.
You guys had like small bipeds at one point, like smaller
Yes,
versions,
so
right?
I originally started with one this
Watson
big,
Jr.
and I said, oh, I'm just going to build a full-size one, and that was a big mistake. I didn't understand mechanics, and when you scale something up that large, metal isn't stiff anymore. It kind of becomes fluid, and there's a lot of slop, which is one of the reasons why I started using the TX2, is that we're trying to characterize some of the slop and see if we can find if the machine can learn to calibrate itself as the mechanical parts change through wear and heat. Yes?
What are the servos and what's the torque?
These are servo. Yeah, they look really big, don't they? So a company called Gearworks makes these. Inside is just a gearbox and a DC motor and a Pololu board, which controls it. Originally it had the PWM style control, which had no feedback. This model, this rebuild, has a serial link through all of them, so now I'm getting the feedback of where the servos are.
Who's the manufacturer
Pololu?
of that
The
servo?
servo, Gearworks. Yeah, so I've actually got my own version of this one with my own controller board. It just doesn't have the fancy case yet, and I've worked a long time on that controller board, so I'm very proud of it. I think I brought it in a couple months ago, and I'll bring it in next month if anyone's interested in seeing what my servo looks like. The bottom line basically is you can build a servo with this kind of torque, fully controlled with SPI or I2C or any interface you want can, and you can do it for, you know, under $200. And it's got torque that'll take your finger off.
Nice.
Yes, exactly. How do you spell Palolo? P-O-L-O-L-U?
Up back, crooked letter.
I believe. Yes, and they're probably watching now through our friends in Palolo because I told them we were online, and I was talking to them today, so they're watching.
It's been a month to
And,
learn.
any other questions? No? All right, thank you, everybody.
All right, so if there are no more robots to show, going once, going twice. All right, so we'll take a 10-minute break. The clock says 8 o'clock, so we'll meet back here at 8:10 for our presentation with Alan.